So there's the first success criteria there. Let's go back into full screen. So we're going to look at negative rotations as well, and trig values. And the second thing we're going to have a look at is, by the end of this lesson, you can find, I don't know how to put this succinctly, but you can find other trig ratios given a starter trig ratio. And I'm just going to pause there for a second and say that typically what I find with students is that they often confuse the angle with the trig ratio. I know that kind of sounds a bit weird, but what I mean is if I said sine theta is 60, sorry, sine theta is a half, what is cos theta? A lot of students try to find theta, or they're kind of confusing stuff. So cos theta is its own entity, it's its own thing. It's the value that is got out of a function called cos. So we put in theta and it returns some sort of decimal value between -1 and 1. So that's kind of how, so if you're asked to find cos theta, quite frequently, not always, but quite frequently, it has nothing to do with finding an angle at all. It's just finding the actual ratio itself. So that's what we're going to cover in the second success criterion today. So if we look back at the end of the lesson and say we can do those two things, that would be like your way of saying, yep, I can tick off my success for today. And as usual with success criteria, if you get to a dot point and you go, no, I'm still not sure about that one, then that's your that's how you can chart your pathway to success, by shoring up your knowledge on that particular dot point. And that could be by getting a tutorial from me, looking up some YouTube videos, asking me for videos, doing some textbook work, whatever floats your boat. Alrighty, so let's do a quick recap from last lesson. I'm going to put a problem up on the board for you to have a go in your workbooks, please. So from now on, I'm going to try, and you can please pick me up whenever you can. I'm going to try and always give you a range for which to find values. So for theta between 0 and 2 pi, okay, so we're just looking at a single positive rotation. Find theta if cos theta is equal to √3 on 2. Now, while you're having a go at doing that, this is another exact trig ratio problem. So there is a chart of, there is a table of values you can look at that we sort of developed over time. I'm just wondering, would it be useful if I gave you a printed table of exact trig values? Would that be something that you would like? Okay, so I mean, I've got one from year 10 Maths Extended that we use for unit circles. So I'll just I'll just upload that to Google Classroom. I can print them out too if you prefer. I'll print them out. There's only 7 of you, so, but I'll put it on Google Classroom as well, so you've got access to it. But just remember, those exact trig ratios will not be in the given to you in the exam, so you have to know them. The bonus is if you know them in the first quadrant, you should be able to work out exact trig ratios in all the other quadrants as well. Okay, so you can refer back to your notes if you need to. Step 1 is find the reference angle. I'm going to go through this on the board, but I'm verbalizing it to try and give you hints one at a time. So the reference angle is the acute first quadrant angle for which cos of that angle is √3 on 2. That's where you look at your table of values and say, ah, yeah, it is that value there. Step 2, in which quadrants is cos theta positive? Step 3, use the quadrant angle to find, use the reference angle to find the possible values for theta, the actual angle. One more minute. And if this is really, really rusty for you right now, if this is really such a slow process for you, I highly recommend you doing some practice work between now and next lesson, or next week at least. All right, I shall slowly uncover the solution. Okay, so I will go cos of theta hat equals root 3 on 2. Theta hat is equal to pi on 6. Okay, 30 degrees. Pi on 6. Try and use radians as much as we can. All students take care. So we have cos positive here and cos positive there. Why did I pick on the positive quadrants? Because what, sorry? Thank you, because cos of theta is root 3 on 2. If cos of theta was negative root 3 on 2, we would be looking at these two quadrants where cosine is negative. But because root 3 on 2 is positive, we need to be looking in the quadrants where cosine is positive. So we can conclude therefore, sorry, beg your pardon, not cos. Therefore, theta is equal to theta hat, which is pi on 6, or theta equals 2 pi minus theta hat. You don't have to do that line. I'm just doing it for completeness, which is 2 pi minus pi on 6. Now, 2 pi, just again, make sure your fraction works okay. 2 pi has to be worth 12 pi on 6. 2 lots of 6 pi on 6. So 12 minus 1 is 11 pi on 6. So there are your two solutions. You okay with that? Alrighty, let's do a related problem. And I'm just going to give you some thinking time first and see how you go for it, how you go with it. There we go. So it's exactly the same problem as before, except now we're looking at theta between 0 and negative 2 pi. Now, I'm going to come back to this screen in a second. So it's basically the same problem as above, except a different range, because I want to flick to the next screen for a moment just to explain what theta being between negative 2 pi and 0 would look like. Okay, and then I'm going to give you a chance to try and work it out yourself. Okay, so these are for negative rotations. So this is what I mean by negative 2 pi to 0. It's a negative rotation. So with the Cartesian plane like so, for positive rotations, we would start from the x-axis and go this way. So that's a positive rotation. So positive rotation goes counterclockwise. So hopefully it's not too much of a stretch of the imagination to see that negative rotations start from the same point but go clockwise. So for example, this would be negative 30 degrees. Okay, so very quickly, 0, negative 90, negative 180, negative 270, and then negative 360. So this angle here is negative pi on 6. Then we would have negative pi on 2, negative pi, negative 3 pi on 2, and negative 2 pi. So you're just going backwards. Hope that's okay. So I'm just going to give you a moment. I'm going to go back now and then give you a chance to just finish that one. So you should be looking at slide 2 and slide 3 to give you some guidance, but you just need to work out how having a negative angle will affect what theta could possibly be. Okay, step 1 is exactly the same. Find the reference angle. Even though we are looking at between 0 and negative 2 pi, we really just do the same thing. As if it were in quadrant 1, positive, we simply say that cos theta hat is equals cos theta hat equals root 3 on 2. So we ignore the fact that the angle eventually has to be between negative 2 pi and 0. Theta hat is always just that acute first quadrant angle. So theta hat is equal to pi on 6. So that is, no, that's terrible. I'll redraw that one. So theta hat, just like in the other problem, is just pi on 6. Okay, so far? All right. So just tell me if I'm going way too slowly. So I'm going to do the rest of it here. The next part, after we've worked out the reference angle, which I'll just put up here, so we've got it as a handy reference again. So the next part is exactly the same. So we say, for cos positive, theta is in quadrant 1 and quadrant 4. Drawing a diagram doesn't hurt. So it means that whatever theta is, it has to fall into those two quadrants. So then we just need to take into account the fact we're looking at the counter rotation. So basically, if I'm starting off from 0 here, to get in, we're going backwards this way. So the first quadrant I hit, I suppose, going this way that we need is this quadrant 4. So what would the angle in quadrant 4 would be? It would be 0, and I have to create a pi on 6 angle here. So pi on 6 in here would be 0 minus pi on 6. Okay, so theta is equal to 0 minus pi on 6, which equals negative pi on 6. or theta is equal to. So the next one is really starting off from 0. I'm going around here, and I have to keep going around until I create a 30-degree or pi on 6 angle here. But because I'm going around this way, thanks. I'm going to have to change the sleeping behavior of my laptop. So if I'm going around the opposite way, then to create a 30-degree angle here, I will have to go a full rotation round back to the start again. So full rotation round and then back a little bit. So that's going to be negative 2 pi gets me all the way back to the start again. And then I'm going to add pi on 6. Okay, so I've gone all the way round, that's in a negative direction. And then to go backwards a bit, I have to add pi on 6. Hope that makes sense. So when we do that, you know, if you know your negative number work, then you're all right there. So you have to subtract pi on 6 from 2 pi, and that gets me 11 pi on 6. But the result is negative. So it's negative 11 pi on 6. Okay? So you very much need to ensure that you are conceptually getting it right in terms of which quadrants the angle is going to be in. That's really important. Maybe these problems are fairly straightforward, but nevertheless, they are foundations upon which we build our ability to handle trig type problems. All right. So what I'm going to do now is I'm going to pause. And last lesson, you were working from exercise 13A, every second problem. For the next 10 minutes, a bit over 10 minutes, I want you to continue to work through exercise 13A. Last lesson, I said skip any problems that had negative angles involved because we hadn't really covered them in class. Now you can cover those ones. If you finish every second problem in exercise 13A, you could quite happily do the other problems while you're waiting. But yeah, we'll only take another 10 minutes to do that. Okay, I'm just going to have a brief look at exercise 13A, question 6A. Question 6, and a bunch of them are the same in that sort of area. So it said, find 3 angles in radians with the same sign as the given angle. And the angle there is pi on 3, which I've now drawn on the unit circle just for handy reference. So it's, oh, actually, that's terrible drawing. That's 60 degrees pi on 3. So there we go. Sorry, I can't handle it. It's a personal failing, I know. So that's better. Now, what they were really asking for is to say, well, it's if we've got the sine of pi on 3, we've got a positive angle here, and so we're looking for where sine is positive, which means we need to look in the second quadrant as well. That's what it's asking you to do. But the cheat would be to simply look at full rotations past that. So if I was looking for 2 other angles, I could say, well, the first angle is pi on 3, that's a given. But if I take a full rotation plus another pi on 3, that would also be in the same quadrant, same value, because the reference angle is still pi on 3. So that would be 2 pi on 3. Oops, sorry, that's dumb. I meant to say 2 pi plus pi on 3, which would be 7 pi on 3. And then if I'm looking for a third angle, then I could go, okay, this is going to turn into a rainbow snail. Here we go. Did I go too far then? No, I don't think so. So that would be 2 rotations, which would be 4 pi plus that handy little reference angle of pi on 3. So that would also give me the same sine value. Okay, so this is sine of pi on 3. This is sine of 2 pi plus pi on 3. And the sine of 4 pi plus pi on 3 would all give us the exact same value, because we end up, where the angle ends up is in the exact same spot on the unit circle. It'd be the same pair of coordinates, the same cos theta comma sine theta. Now, I'm just going to leave it there with that. Now, that wasn't really what it was asking you to do, in that it was really asking you to think about what alternate quadrant would this be in and work out that angle and so on. But I think it's just important for you to appreciate that there are, in fact, an infinite number of solutions. So if that's if we've got the sine of pi on 3 is equal to the sine of 2 pi plus pi on 3 is equal to the sine of 4 pi plus pi on 3 is equal to, etc., forever. So there's an infinite number of solutions. And when we come to graphing the function of sine, we will see that very much made real, where we can see that over a period of 2 pi, the function repeats itself, and it's called a periodic function as a result. It also means that if we're looking for a full solution set, like an entire solution set, all possible values of theta for which sine of theta equals a half, for example, there's not one solution, there's not 4 solutions, there's actually infinite solutions, and we need to have a way of articulating infinite solutions. The bonus is there is a way of articulating it. So that's just a heads up for what's coming, I suppose. Alrighty. Here we go. Given sine theta is equal to 0.25, what is, so here we go. Oops. Find cos theta. Any idea of approach? Hot tip, you do not need to find theta. This is what I was saying at the start of the lesson. You do not need to work out what theta is. One extra hot tip, although I would let you use a calculator for this just to save you the numbers, technically this can be done without a calculator. You could graph it. That's good. I like that. I'm going to go for a shortcut in a second, but what you just said there is good. Okay, either don't want to join in or not too sure. Either way is awesome. Let's get on with it. Just to remind you of this little property though, and this follows on from what you were saying, Ollie, that in the unit circle, that's a distance of 1. Oh man, it's getting worse over time, isn't it? In a unit circle, the coordinates are cos theta, sine theta. Okay, that's what you were saying, wasn't it, Ollie? And it has unit 1. It forms a right angle triangle where the distance here is cos theta and the distance here, the vertical distance, is sine theta. And therefore we have the notation, so we have the result from Pythagoras that sine squared theta plus cos squared theta is equal to 1. Now this is a really important trig identity because we can rewrite that particular identity like so. Sine squared theta is equal to 1 minus cos squared theta. And similarly, we don't need this, but cos squared theta, or do we need it? No, we do need it, sorry. I chose the wrong one. I only had a choice of 2. Similarly, cos squared theta equals 1 minus sine squared theta. And the astute amongst you might see that 1 minus cos squared theta or 1 minus sine squared theta, both of those are a difference of 2 squares. It's a dots thing. We don't need it for this particular problem, but I thought I might just point that out. Okay, so if we need to find cos theta, we can use this identity here in order to solve it. Because we can say for the solution, cos squared theta is equal to 1 minus sine squared theta, which is equal to 1 minus 0.25 squared. Just remember that's what squared theta means. It doesn't mean you square theta. It means that you're squaring the value of sine theta. That's basically how it's supposed to work. Okay, now I'll just put the calculations down here on a piece of paper so I don't have to refer to a calculator. So that means cos squared theta, this is where I'd probably let you use a calculator, but technically you don't have to, is 0.9375. Oops. So 0.938 to three significant figures. And therefore cos theta, just by square rooting both sides, is the square root of 0.9375, which is 0.968 to three significant figures. There we go. There's cos theta done. So that's all right, isn't it? The next one on slide 11. Give you a second to do it yourself maybe, or at least think about how you would solve it. Now this kind of question, just while you're taking a moment to try and solve it yourself, this kind of question is very much a paper one kind of question. The only thing really that makes it difficult is that it'd be a bit of a pain in the butt to find the square root of something like 938, and even squaring 0.25 and then subtracting it from 1 is annoying enough to not want to have to do it. So as a paper one question, a calculator free question, your numbers would be a lot simpler than that. Even though 0.25 doesn't sound that complicated. Or alternatively, you wouldn't be asked to use the Pythagorean identity, that's sine squared plus cos squared equals 1. You wouldn't be asked to use that. It would be some other kind of related problem. But this idea of given sine theta equals a number, find something else, is a pretty common paper one question. Okay, so approach. What do people do? Can I pick on people? Who can't I pick on? Okay, anyone else I can't pick on? Right, Ashley, I haven't heard from you for a while. What did you do? Just the process, just the thinking behind there. What did you do? So you used that particular identity, that tan equals sine on cos. Did anyone take a different approach? If you did, and you're just a bit too shy to say, I'd love to see what it was, this is the approach I would take. But there may be other approaches that I'm not thinking about, but that's the approach I would take. So sine theta over cos theta, and that would give you 0.258. And then you're done. So, in a paper one, it might be something like sine theta is 0.25 and cos theta is 0.97. What is tan theta? And so you're just doing a fairly straightforward kind of calculation there for a paper one kind of thing. Okay, question C. Just want to double check that's what I want to do. Yep. What is sine of pi plus theta? And remember, we don't know what theta is. Notice that so far we've covered two problems without needing to know what theta is either. Okay, so the solution to part C also does not require you to know what theta is. Okay, let me unpack that for you now that you've had some thinking time. I am going to unpack it for you, but I do want to say that at the end of it, I'm going to say there is a simple shortcut. So don't stress too much if you're worried about the unpacking. I just know that for many people, not all, the unpacking helps consolidate your understanding. So we don't know that theta is an acute angle. We don't know whether it's obtuse. We don't even know if it's like 10 rotations wide. All we know is that sine theta is 0.25 and therefore it has a positive value. Okay, so what I'm about to do here is not necessarily how I would solve it in general principles, right? So this is just for thinking. I might even write that in so that you've got it in your notes. Okay, so this is thinking as opposed to solution writing. So sine theta equals 0.25. Therefore, theta is in quadrant 1 or quadrant 2. Is that okay? So that means that theta is here. Or here. Is that okay? Now, what I'm not going to do is I'm not going to look at counter revolution. So is it enough for me just to say that if we were looking below 0, then we're just, it would be still in those two quadrants. It's just that I would have gone all the way around here for theta or all the way around here for theta if theta were negative. And if we're talking about more than one rotation, then theta would be, all the way around and then start again. And then all the way around and then back to that point again. So although I'm just going to treat this like as if it's between 0 and 360, it's because if I extend to beyond 0 and 360, 0 and 2 pi, it's the same sort of, we get it to the same spot. So what does pi plus theta look like then? I mean, I've just done a random angle there. I don't know what that is, but pi plus theta would be an extra 180 degrees. Okay, so pi plus theta is going to end up being down here. So it's going to be in quadrant 3. And if theta is over here, then if I add 180 degrees, if I add pi to that, then theta would end up being sorry, I shouldn't put theta there. There. So can you see it's kind of got like a symmetrical quality to it? So it would end up in quadrant 4. So in both cases, adding pi to theta, wherever theta must have ended up, we'll just get it to the opposite quadrant. Okay, and in the opposite quadrant, sine is negative. Okay, so that's the thinking, that it actually doesn't matter what theta is. And here's the clincher, this is the shortcut. It behaves as if theta were in quadrant 1. It behaves as if it was like that. In other words, because sine theta is 0.25, we know it's positive. So we can therefore conclude that adding pi to theta will give us the negative of that. So that means the solution is something like this. Sine of pi plus theta is equal to negative sine theta, which equals negative 0.25. So the reason we can do that is because it just keeps on shifting over two quadrants. So pi shifts it 2 quadrants, and therefore wherever it started, it'll get there. And in a similar way, if sine of theta is equal to, I'm just going to make a value up, say negative 0.2, then that would mean, I'm not going to draw it in, but that would mean that it would be in quadrant 3 or quadrant 4, and adding pi to it would get it either into quadrant 1 or quadrant 2. So it still flips the sign. So if sine theta equals negative 0.2, then sine of pi plus theta would be equal to the same thing, negative sine theta, negative 0.2, which would be positive 0.2. So that's a symmetrical arrangement we have with sine, where pi plus if we add pi to the angle, then it just changes the SIGN, the sign of the value for sine. Okay, it is 9:28. I'm not going to get you to do any more work today, so you can pack up. And we will start with a brief reminder next lesson, followed by plenty of practice work on that, plus looking at how to find